Okay.
Okay. Good. This is Jan Pechanec. Hope I get your name right.
Yes.
He's from SunSSH. There's Mark Phalan, who is also giving part of the talk, which is over there. He's actually working here, but he's from a small town south of Dublin, 25 kilometers. Well, you're talking about new security features in OpenSolaris and beyond. We are very curious what you have to say to us.
Thank you.
Thank you.
So, hi, me and Mark, we work in one of security groups in Solaris software. This group is responsible for several technologies like Kerberos, SunSSH, PKCS engine for OpenSSL, part of key management framework, PKCS libraries, and more. You know, we have more security groups, but you know, there are overlays in what we develop and who. So this is a disclaimer. I'm going to show you some features that are integrated in Solaris already, and I'm definitely going to show you some features that are in progress. So this is not our commitment, you know, what is going to happen. You know, when I say it's going to happen, it's just, you know, like maybe, you know, or we hope that, you know, it will happen. It can change. What I'm going to tell you about. So there are two projects about file system encryption in progress, LoFi encryption and ZFS crypto. Then I will tell you what is key management framework and how SunSSH is going to use it. Then I have a section about PKCS 11 engine and how SunSSH is going to use it to speed up transfers on machines that that have hardware accelerators. Then there is something about libmd, Kerberos enhancements, validated execution, and hopefully I will also get to Solaris trusted extensions and demo. So LoFi encryption. LoFi is an existing loopback driver, file driver, so that you can mount a file as a device. So it's existing thing. It is now in progress to be extended to support encryption. There will be no data integrity protection because AES CBC mode will be used, and this mode doesn't have a built-in integrity protection. And you know, if you imagine that you have application, you have a file system, and you have a driver, then definitely you don't want the driver to expand data that file system wants to write. So I had a demo. Unfortunately, just a couple of days ago, somebody did a commit, and it broke down. But I can at least show you. You know how it is going to look like. So what you do, you know, to test it, you can just, you know, create a file, and then you use LoFi admin to request encryption, and then, you know, it's the same as it was before. You just mount it, and any file that is going to be in the directory will be encrypted. ZFS on-disk encryption. It has several phases. The most important is the phased one, of course, because that's the phase that will bring you the encryption. We have datasets. Dataset is a file system or ZFS volume. ZFS volume, it's a part of pool that behaves like a device. So we have per dataset policy for enabling encryption, which means that we can't encrypt just you know, one file or one directory, which is something that other file systems can do. However, given the fact that ZFS is very good at file systems, you know, it's very cheap to create a new file system, then basically you have the functionality there too. So, you know, you can just create a file system for one directory and you have it there. It's development complete and under code review now, so hopefully it will be in OpenSolaris pretty soon. Use set For every data set, the key is generated randomly, and you put all those keys into one pool, which is guarded by one master key. This master key, you can type it in, you can use a file, with that master key, or you can use PKCS 11 token, hardware token, so that this key is never extracted in an unencrypted form. As I said, there are more phases, remote key management, using KMF, for example, secure deletion, key escrow. As far as I know, these are not even under design, any design, so this might happen and might not. Crypto framework. You heard about it right now from Wolfgang, so I just I kept this slide here so that it's at least a little bit complete, but I'm going to skip it. I will just show you something that Wolfgang didn't show you. This, sorry. So this is Niagara 2. You can see some, you can see providers. You can see user level providers, which is PKCS 11 kernel library and soft token library. You see kernel software providers, so that cont'd kernel can use it, and you can see hardware providers, which is probably the most interesting part of that. Here is the N2CP and NCP providers. NCP is for RSA, DSA, Diffie-Hellman, and N2CP is for symmetric crypto and digests. Okay, so yes, that's it, I guess. OpenSSL PKCS 11 engine. So OpenSSL engine is a container for an implementation of crypto algorithms. This means that OpenSSL has its native code for AIS, RSA, DSA, all that crypto stuff. However, application can ask to offload some operations into that engine, which is another code, self-contained code, and you can, for example, access hardware crypto providers. So the PKCS engine is there so that we can access crypto framework from OpenSSL. The engine is internally developed at Sun. It's not shipped with the OpenSSL source code. There are some reasons for that, and some work is needed to do before this can happen. I'm sorry. And a patch against the latest OpenSSL version usually exists. I have to modify the patch against the latest OpenSSL version, which was released a month ago. I just didn't have time for that. I will show you where it is if you are interested. And originally it was developed to accelerate Apache on Niagara 1 using NCP. So, what is important is that your application doesn't have to be changed aside from a couple of calls. You just load the engine. You ask for it, and then you init it. That's all. That's all it should work, if the engine is there, of course. And then you just say what mechanisms you want to offload. It's not about mechanisms, because, for example, you can say that you want to offload just AES. You have to offload all the symmetric crypto or nothing. And then, you can just, finish it. It's just code I ripped off my, SunSSH prototype using that, so please ignore all those XXX commands. So the situation, so it was developed to accelerate Apache mostly. So the situation changed quite a lot with N2CP when we shipped Niagara 2 with N2CP hardware provider that can accelerate digests and symmetric crypto. So now we have a lot of potential consumers right now, because a lot of applications do symmetric crypto or use digests. So this is what we have now. Ignore this because this machine is already BFU'd several times, and there's some of my code and also some of other code that is not in OpenSolaris yet. So we can see that the engine can offload like these operations. It works that you call init from the OpenSSL, the engine looks around and finds out what it can be offloaded, and returns basically an array of mechanisms that tell OpenSSL what can be offloaded and what not. So if there is an operation that is not on this list, OpenSSL stays in its native code. Mainly for SunSSH and its acceleration, we needed to add some new mechanisms, especially counter mode for AES, because that's the default cipher mode that we use for SunSSH. So this is also under development. I hope that like in 2-3 weeks I will put this back to OpenSolaris, and then I will start testing my SunSSH prototype. So SunSSH and PKCS 11 engine support. The problem is very easy. SunSSH is slow on Agara 2 because all SSH implementations are slow. The problem is that SSH applications are usually single-threaded. I just know about one patch that brings multi-threaded support to OpenSSH. What can we do? We can use hardware acceleration, or we can use parallel processing of data, but with counter mode only. If you know how it works, then we can't process data in parallel with CBC mode, for example. So hardware acceleration is the way to go now, and there were two ways to do it. To use OpenSSL PKCS 11 engine, because OpenSSH and SunSSH, which is a fork of OpenSSH, uses OpenSSL, or we could use PKCS 11 API directly. Definitely, it looked faster to use the engine through OpenSSL. It wasn't that easy after all, but still, it was easier than to switch to PKCS 11 API. So how fast can we go? So there is a 100 megabyte long file, which I'm going to encrypt right now. Oh, sorry. So it takes roughly 10 seconds. Sorry, I didn't tell. The problem with SSH is that we have 64 CPUs in Agara 2, but of course, since SSH is single-threaded, then you use just one CPU for that. So that's why it is slow. PSR info, you can see that there are a lot of CPUs we can use. So sorry. So it takes 9-10 seconds to encrypt 100 megabytes of data. So, however, if we use the engine right now, it's a little bit faster. It takes like 3 seconds. So that's how fast can we get. You can see that at best we can, like for now, we can speed up SunSSH like 3 times. It will not be 3 times, and I will explain why. But this is like this is the top we can get. This is not my code. This is OpenSSL. You know that the first parameter you can use to encrypt, sign, whatever, and you ask for an engine using option -engine, and you add the name there. So. Okay, so why it's not as fast as hardware can be? Because there is inherent overhead of crypto framework. also, there are still some small data packets that must be processed, and the overhead to offload to hardware is quite big. And also, each SSH packet is processed twice. First, HMAC is computed over data, and then it's encrypted. So it's not just encryption. This is, that's what I showed you, just a minute ago. It was just encryption, no HMAC. Just one, because you just offload the operations to hardware. Yes. So I'm sorry. I had everything prepared, but after the VPN disconnected, I have to do it again. So I'm going to transfer 100 megabytes of data through that's the old SunSSH. It will take around 11, 12 seconds. So since I already use BFUT machine, then this is the modified SunSSH that uses the engine to offload all those operations, and you can see that it's faster. Okay, and it's not 3 times faster, but it's 2.5 faster because the initial key exchange and the logging in is the same. It takes like 1 second. So this is another project that I'm working on right now, and as I said, I hope that I might be able to put it back at the beginning of September. I hope it could be in OpenSolaris, but see that disclaimer again. So it might not happen. It might be later. So that's all about SunSSH and PKCS7 engine. Key management framework. What is it? So if you wanted to write a PKI application, public key infrastructure application, you can use NSS, which is based on Mozilla toolkit. You can use OpenSSL. You can use PKCS7 API directly. You can use GNU, TLS, and I guess that you can use many more technologies, libraries or applications. The problem is that they are not compatible with each other, and there is no PKI policy enforcement. For example, you can say system-wide, from now on, I want to ignore or expired certificates, or I want to use them even if they are expired. So this is what KMF can do for you. KMF is a framework. It provides a consistent management interface from command line using PK tools, so you can manage keys, stored in tokens. You can sign, you can verify data. You can use it as a simple certification authority. Now, it's not in Solaris 10 that particular feature, but in OpenSolaris it's already there. And from applications you can use KMF API. This API hides all the details of the underlying key stores, so you don't have to care whether you are accessing NSS databases, OpenSSL files, or PKCS7 tokens. Of course, KMF uses OpenSSL there, but you don't have to care about it. And as I said, KMF provides a system-wide security policy. Any application can use, its own policy, but if during the initialization it doesn't say which policy to use, the default one will be used. The default one, which is in etc security somewhere. So big picture. What is this? Sorry. So key management framework, and you can see like future integration with KMF, light blue. The only thing that is happening right now is that I am using KMF in SunSSH for X509 authentication, which I will show you within in a few next slides. What is important is that you can see there are key management providers, PKCS 11, NSS, and files. Files means OpenSSL. So if there is any need for any other provider, then the provider will be plugged into the framework, and it will work. You can just use the same KMF API, and you can use another key store or type of key store, for example. The image is not exactly correct, but I think this is the only one we have. Then, for example, certificate validation providers, they are not self-contained. The validation is in all key management providers. In Solaris 10, the API is there, but it's a different one. It's a private API, so we are not supposed to use it, and it's not pluggable. The framework is not pluggable. New API is in Nevada. It's a public API, so you can use it, and it's pluggable. As I said, that you can, or I think that somebody is already, designing or working on a new provider. I don't know what is that, but there will be a new one, I guess. And there are also some new things to come. Certificate path validation. Now we can validate just path lengths of one. So you can say, okay, there are certificates in between, and just go the chain up there and verify everything. And what is missing is certificate to name mapping, which is I will need it for SunSSH. You have a certificate, and you want to authenticate with that. Where's the user? Is it a subject? Is it an alternate subject? Is it something else? Is it a digest of the certificate? Mapped into some username in another file. It's something that PEM PKCS 11 open source project has, and we plan to have something similar. PK tool, I told you that it's for managing certificates and keys, and KMF CFG is for managing policy files. So some customers want us to add X509 authentication with for authentication, for host authentication and for user authentication. There is a public key authentication. Definitely, you know it. You remember that message that if you want to continue connecting because the host that is on the other side is unknown to your client. You say yes, and if there is somebody listening or willing to change the packets, then you are screwed basically, because you can say that the host key is a different one from the one that is stored in the server. There is a little problem. There is no RFC for X509 pub key authentication. It's a part of public key authentication, which is in RFC 42.50.53, I think, but it's not defined like how it looks. What is there. How to send a certificate. There are just two drafts. One draft is that what we wish to have, and another one is what is implemented right now. And since IETF SSH workgroup goes down, it might be quite hard to finish it. But I met some guys from other companies in San Jose this year, and we will try to reopen it and somehow finish the draft into RFC. And as I said, I even can continue until we have certificate to name mapping in KMF. Example usage of KMF API. So the objective is to validate a certificate. What is good with KMF API that the certificate you want to validate is the only one, it is the only thing that you need to provide to that call, because everything else is in the policy. For example, the trusted anchor, which is the certification authority certificate, is already in the policy file. So this is again this is ripped off from my SunSSH prototype. You can see KMF validate certificate here. It has 3 parameters. One is KMF handle, which is the handle that that has the information about the policy file, and you have just some attributes and a number of attributes. And the only attribute setting here is the certificate data, which is a certificate in a SN.1 form, and there is just result attribute, which, as you can see, I'm checking here, to see whether the certificate was validated. If you use anything else, then definitely you will have to write, more lines of code if you use OpenSSL, for example. So I must say that I really like, KMF, and I think that SunSSH is the first, first application under in progress, that is using KMF aside from applications that are part of KMF. libmd. It's a very small library, message digest library. It was in Solaris. I hope that I'm not wrong, but I'm quite sure that it was in Solaris before OpenSSL was integrated. So it was quite logical to extend libmd5 to libmd and provide SHA-1 and I think even SHA-2. I'm not sure right now. It doesn't make use of a crypto framework. It's just small library. If you want digest only and very quickly, just you can use it. And one reason for not to use OpenSSL might be that it's ABI compatible. Maybe you know that in Solaris 10 we have still 0.9.7d OpenSSL, which is patched, but it's 9.7, and in OpenSolaris we have 9.8, and those two libraries are not compatible, ABI compatible. So if you build something with one library, you just can't use it against the other one, because header files changed, and it's quite probable that it will crash, even if you rename the library. Short source code example. Yes. So I have a SHA-1 example here, and so. The left example is using OpenSSL, and the right one is using libmd. So you can see it's very similar. There is just one. There is underscore. Edit, and otherwise it looks the same. So it's very easy to use, and it just opens a file and computes a hash over that file. So Mark works on Kerberos, so definitely he knows something about it, which I'm not almost. So please.
Yeah, so as Jan already mentioned, my name is Mark Phalan, and I work as part of the Kerberos development team here in Prague. And I'm going to just go over the couple of new features in Kerberos that have already been committed and a couple that we're currently working on. So the first one is client-side zeroconf. We made a couple of small changes, small enhancements to Kerberos to make it work in some environments with no explicit client configuration. So for example, in the Sun network, Swan, you can simply type K in it and it will just work with no explicit configuration. I've listed the couple of changes that we made. I'm not going to go through them, but they're all relatively minor. The next thing is LDAP support in Kerberos. So prior to the LDAP putback, the only database type that was supported was DB2. So the DB interface was changed, and now they're implemented as plugins. So LDAP was implemented as a plugin, so all Kerberos policy and principal records can be stored in LDAP. The DB2 support then was also abstracted and also implemented as a plugin. So it's kind of nice because it makes it easy to potentially implement more back-end types. For example, we were thinking maybe we'll do a MySQL or a SQLite plugin. So it also leaves the door open for a multi-master KDC, because if you separate the Kerberos daemon, the KDC, from the data that it's using, you could potentially have multiple KDC daemons running, and if one goes down, the database is not associated with that daemon. The second KDC can potentially access it, but that's not supported yet. But it's just a possibility. The latest major feature to go in was K-Client version 2. K-Client is a Corn shell script which eases client configuration, so you can run it in an interactive mode or non-interactive mode, and it should configure the client-side Kerberos. Basic additions to this were to enhance the types of environments that K-Client can work in. So it works now much better with non-Solaris KDCs. For example, Shishi, Heimdall, even Microsoft Active Directory. It can do a Microsoft Active Directory join. Sean, the guy who was working on it, I think he worked very closely with the sys team on this. So actually the sys team are going to be using K-Client to do their Active Directory join. So we regularly resync with MIT Kerberos. I mean, we are essentially MIT Kerberos plus some bug fixes plus some features. We're fully in sync with 1.4.3. And also we've got major features from 1.5 and 1.6. The current MIT version is 1.6.3, and we're doing a full resync with that. In fact, the LDAP support is taken directly from MIT. Plus, we just add some bug fixes and that sort of thing. PKCS is one of the projects we're working on. It's not yet put back into Nevada. Again, it's a feature that comes from MIT, but it allows you to do the initial authentication to the KDC using X509 certificates. So instead of the KDC and the Kerberos principal sharing a secret, you use public key cryptography to get the initial TGT. So it's kind of a nice place to integrate Kerberos and PKI. It'll be implemented as a pre-authentication plugin, and it currently uses OpenSSL because that's what MIT used. We're probably going to convert it to KMF, or at least KMF and OpenSSL, to make use of that Solaris specific feature. The final feature that we're adding, which is also quite close to completion, is Kerberos master key encryption type migration. So when you initially create a KDC and you create the database, it will encrypt all the policy and principal records using the key at creation time. By default, that's single des. You can't change that key without destroying the entire database and recreating it. So this project is aimed at solving that. So you can take an existing database and you can migrate the data from the original potentially DES key to, for example, AES key, without destroying any of the data. What's kind of interesting about this project is that it's being done as part of the MIT consortium, which is, if you go to kerberos.org, it's a new consortium which Sun's one of the founding members, and MIT obviously is a major player there too. But one of our engineers is working on this project, but the commit is going to happen into the MIT code base even before it goes to Solaris, and then we'll later resync it over. So that's it. I'm going to hand it back over to Jan.
So, validated execution. It's another technology that is under development, and it's a project that should bring automatic integrity verification of all code before execution. There are technologies right now that can do hashes over all files, in the file system, and you can check whether the file system is, whether there are any modifications. But there are problems. There is inherent race condition, because after you check it, if someone changes the file, the executable, that you are not going to find out. And see that application maybe something else is compromised, and the application will always tell you that everything is okay. So what is this? It means that we validate it right solution, and something is called secure boot. Just click and just something when you're in a specific way, way is enforced software, so to trust the systems and not compromised. Very early projects book, which is like third point. Something's called which new wall, and when the are running, then update over stored it to the this it's a that can verify and also can store information. And, if those hashes, then continue. So test with structures all files in boot are so all in library and init in daemon, which is if the daemon is not running. Call exact the some for interface already is correct, and it will run. There's something like chain of trust. So if you have the hardware, you can trust it to trust the hardware. So since it's already verified that and by the kernel, so it's platform you don't have to have it, but you must download it. That it's compromised. It's compromised. You are going to find it, or you find it. Only 5. So administration principle is simple. If it's hard to administrate it, BART, which is a basic recording tool, will very good. Should have it. So, for example, manifest innate, and that manifest will be signed by a certificate. Sorry, signed by the key and okay. So I'm not going to show because I don't have time. I'm happy to show you if you want presentation. I can show you. It's cool technology. I have as I said, I'm talking about all new OpenSolaris announcements that out. We are doing a lot of things, so you can use OpenSolaris. There are some things you can do if you like. There are and blog. I'm publishing this engine patch there, so to use the engine on something that Solaris and on the engine OpenSSL and you. I think that's all. Questions, I'm happy to answer them. Solaris, then you can download the engine, patch OpenSSL, and you can have it. I think that's all. If you have any questions, I'm happy to answer them.